This is your last day, day 30. Hopefully, I'll do this in time because I have to go to class. Um, so, I took a few questions from early in the beginning of the year and I put them here. First one, Ed has 56 red jelly beans, 96 blue, 168. He wants to divide it among his friends. He wants to make sure everyone gets the same. So, what is the greatest number of friends he can divide these evenly to? So, this is definitely a greatest common factor problem. Hopefully you remember that. So one of the ways that we can do this, and there's several ways, okay? One of the ways you can do this is solve it by using a ladder method. So over here, we're going to get, what am I writing there? Oh, okay, so I need some room to write. Oh, okay, yeah, why don't we do that? Okay, so I see what, so let's see if I can sneak, oops. Here we go, somewhere at the bottom. So 56, 96, and 108. Okay, you want to find the GCF of that. So you can start with small numbers. 2 goes into that 28 times. 2 goes into this 48 as well. And 2 goes into this 54. 168, by the way. So it's not 164, it's 82. Okay, so this one is 84, sorry. Alright, so we can go again. 4 works. Let's pick a higher number. You could have gone with 2, but 4 is 4. 4, 28, 7, 12, and 21. So GCF is these two numbers on the side. 2 times 4. Remember, you're multiplying. So the biggest number of friends I can give this to is 8 friends, and each friend will get 7 of the red, 12 of the blue, and 21 of the yellow. And that's the beauty about the ladder method. It gives you the answers at the bottom as well. Okay, so next one, hamburger buns are sold in packages of 9, and then patties are sold in packages of 12. How many do I need of each? How many do I need so I can have the same amount? So if I go to the supermarket, one's come in 9s and the other one comes in 12s. I can do it like this. So this is my buns. These are my patties. I buy 1 bag of each. I have an odd number. I don't have the same number. So let's buy another bag of buns. That would give me 18. I still don't have the same. Let's add another one here. Nope. Not the same. Let's add another one here. Still not the same. Another package of buns. So I got 27. So that's still not the same. I want to walk out with the same number of buns and patties. So let's add one more here on the buns. Ooh, look at that. So I need to buy 1, 2, 3, 4 packages of buns and 1, 2, 3 packages of patties to walk out with the same amount. The same amount would be 36. This is an LCM problem. Okay, you could have done ladder method for LCM as well. This one, hopefully, I don't know if you remember. So you have 3/8 of a pizza, and you're going to give it out to 4 friends. It's a division problem. So the way we did it in class, we put this over 1. 3/8, we found a common denominator, which in this case is just 8. But we got to change this guy to 8. So 1 becomes an 8 times 8, and 4 becomes an 8 times 2. So it's, what do you call, times 8 on top, sorry, what did I times 2? So if I multiply 1 times 8 here for this to become an 8, top is also 8, so whatever I do to the bottom, I must do to the top, times 8 times 8, so it's 32. When the denominators are the same, I can cross them out, and this will simply become 3 divided by 32. So each person gets 3/32 of a pizza. Alright. Here, let's do this one right here. I can cross out these. Equals to 5 over 4. You can leave it like that. It's completely fine. You don't have to simplify the change, but if you wanted to, it was 1 and 1/4. 7 divided by 7/9. Let's change that. Make it over 1. Right, now we have to find a common denominator. The common denominator is going to be 9. That's already a 9, so 1 times 9 over here, and 7 times 9, so that becomes 63 over 9. We can cross this again, and that becomes 63 over 7, which again, you can leave it like that, or change it to a 9. Let's clear up some of this page. 2/3 divided by 4, let's put that over 1. Common denominator is 3. This one's already a 3, no changes, but this one had to be multiplied by 3 to get this 3. So the top is by 3, we get 12. So cross this out again. 2 over 12. It's completely fine. I'm not even going to simplify. Here, the other side. Your LCM is 35. If I change the bottom, I must change the top. So the 7 was multiplied by 5, so the top is by 5. 4 times 5 is 20. This one was times 7, so top is times 7 is 28. So I get my problem, 20 over 35, 28 out of 35. Let's cross this out. And I get 20 over 28. Okay. If they ask you to simplify, be my guest. But if they don't, why do you have to simplify? It's not necessary. But look at your multiple choice. Sometimes if you look at your multiple choice answers, you'll find a simplified version. So sometimes it does help. Wow. Okay. So these two, the main idea here, okay, I'm not going to divide this, is that when you roll it like this and you set it up the problem, point 2, my main concern is that no matter what, is that you did this. You moved the decimal 2 places over, so that became 78. If I move the decimal 2 places over inside, I must do it outside. Outside, I must do it inside again, so I'm moving it 1, 2. I'll add a 0. So the new number inside is 4846920. Okay, and you can always double check your answer in a calculator. So, but tomorrow when you don't have a calculator, make sure you move your decimal on the outside, however many necessary, so that this becomes a whole number, and adjust the inside as well. Okay, product 324 times 0.56 times 54.82. What's important here is that whatever answer I get at the end here, okay, I need to have 1, 2, 3, 4, the same number of decimal places that my 2 factors over here have. So there's 2 decimal places here, 2 decimal places over here. So my answer should have a total of 4 because there's 1, 2, 3, 4. So whatever number you have, and I'm just going to make this up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 5. So let's say that's our answer. Our answer should have 1, 2, 3, 4. Our decimal should be here. Should have 4 decimal places. Okay. Integer, not integer. What's an integer? These are integers right here. All the negative numbers. -3, -4, -2, -1, 0, and all my positive numbers. And that continue on that side and this side as well. So, no decimals, no fractions. 1 over 8, not an integer. -4, not a negative integer. Not. This one is a negative integer. 15.8, nothing. It's not an integer. -3 and -3 over 4, not an integer. -39, it's a negative integer. 81, a positive integer. And -2.7 is just a negative rational number, which is not an integer. Okay, so integers, remember, are 0, all your whole numbers, the 0, and then the whole numbers, but they're negative counterparts. Okay? Okay, when do we use integers? Here are some situations. You take the elevator to the 14th floor, so you're going up, that would be plus 14, I would use plus 14. The company posted a yearly profit of $1 million, that means they made $1 million. Temperature 7 below usually associated with negative. The submarine dove 500 feet, -500. And the plane flew at an elevation of 30,000 feet. So that above the air would be plus 30,000. I don't even need the plus sign. Okay. Again, it's just something that we haven't done. So so it's very easy today. 5 less than 3 times the number. Okay, let's write 5 less. 5 less than 3 times the number. This is a turnaround word, less than, so that becomes 3n minus 5. 8 less than the quotient, again, turn around. So 8 less than the quotient is a division of a number 2. So let's switch that around. N over 2 minus 8. 9 times the sum of a number and 15. Let's protect that. Number plus 15. The sum of twice a number and 7. So twice a number is 2 times a number plus 7. 1 plus the product of a number and 5, or 5 times n times 5. A number less than 25, again, turnaround word, so make sure you switch it. So n minus 25 becomes 25 minus n. The sum of a half a number. How do you write half a number? Well, here's a number divided by 2. That's half. And sum plus 4. This one, 7 less than, again, another turnaround word. 7 less than 1/3 the sum, protected, of a number, oh, and this 2 over here goes all the way here. Sum of a number and 2. You got to turn around, so erase that, minus 7. All right, how do you change a percent to a decimal? Take the decimal percent sign out. Put a decimal, move it 2 spaces to the left, 0.86. Likewise, if I'm moving from a decimal to percent, I'm going to move the decimal to the right, and that becomes 34%. How do we change either of these to a fraction? Percent is something out of 100. The 34% is something out of 100. 34 out of 100. Okay? And here, 0.86, I'll use this from decimal to a fraction. Well, the 6 is in the hundredths place. So this would be 86 over 100. Okay? Fraction. How do I take a fraction and become a decimal? Change that to a decimal. You're going to take 5 and divide it by 8. Not the other way around. Please don't do this. 8 divided by 5. Okay? It's 5 divided by 8. Numerator goes inside. And this will give you 0.625 after you do it. So, if you divide 5 divided by 8, you get 0.65. Want to change that to percent? Let's move that decimal 2 places over. Goes 1, 2. It's in the middle of 2 and 5. And add the percent sign. Okay? And that time, shoot. Last question quickly. Bill is in a class of 15 boys and 35 girls. 40% of the students in the class take the bus to school. How many don't take the bus? So 40% take the bus. How many don't take? That would be 40% take and 60% don't take. So let's find out how many don't take. Well, 60% don't take the bus. Set up your proportion. 100, 60. Total number of kids in this class, 15 plus 35 is 50. Is there a relationship? Yes, there is. Divide by 2. And this divided by 2. That gives you 30. So 30%, which is a 60%, or 30 kids, I'm sorry, which is a 60%, don't take the bus to school. Okay, that's it. Bring some chocolate tomorrow. And we're done. No, not done.